Welcome everybody for the InduSoft Web Studio Cloud Computing webinar. I appreciate you taking the time for this webinar, and at the end of the presentation we'll be taking your questions, so feel free to write your questions on the questions box from the WebEx or even on the chat. And after the end of the presentation, we'll be sending the copy of the PowerPoint and video of the presentation to all participants. So just to get started, the agenda will be pretty much first InduSoft presentation with Larry Combs and myself. Larry is going to talk about cloud concepts like definition, essential characteristics, deployment modules, service modules, benefits, and challenges, and I'll briefly describe some typical architectures of cloud-based applications within the InduSoft Web Studio. And then Darryl Vipond from Vipond Controls will demonstrate a real-world application, cloud-based application deployed within the InduSoft Web Studio. He'll discuss the background scenario, the InduSoft solution, the benefits achieved by this solution, and his plans for the future. So, having said that, I'll give the word to Larry, and he'll talk about the cloud concepts.
So, cloud computing, basic definition on the screen. Cloud computing basically gives you convenient on-demand network access, as it says, to a shared pool of servers. These and resources, which include networks, servers, storage, applications, services, basically all the computing resources that you might need to run your application and access, have your users access the application as well. Rapidly provisioned is one of the key definitions of cloud computing. Being able to rapidly add resources and expand resources as necessary. And one of the other keys, as we'll talk about later, is doing all this with minimal management effort and very little service provider interaction. There are 5 broad characteristics of cloud computing: on-demand and self-service, broad network access, resource pooling, elasticity or flexibility, and measured or metered service, basically pay on demand. The on-demand self-service, basically being able to provision computing resources as needed, again, without requiring human interaction from the service provider. So the user of the service can basically add and remove resources as they need, when they need. Broad network access. One of the keys to cloud computing, and one of the reasons people are moving to cloud computing, is the ability to access the resources on the cloud via standard access mechanisms using web and clients, using mobile phones, tablets, laptops, and workstations. Resource pooling is basically the ability to take resources from multiple physical and virtual pools and dynamically assign them as needed based on demand. That could be done automatically, or that could be done manually through efforts on the actual consumer or customer of the service. The ability to be location independent. Most of the cloud providers out there today provide data servers throughout the world. So if you have customers in different localities, you can deploy your application in such a way that consumers access your application using an endpoint that's near to them. Rapid elasticity. Basic elasticity is the ability for a customer or consumer to scale outward, upward, or even reduce the size of their application based on demand. From a user perspective, the resources and the capabilities for provisioning appear to be unlimited based on the services provided from the cloud, and they can be provisioned at any time as needed for the consumer's application. The cloud is also a measured or a metered service. Basically, it's pay on demand. If you add compute resources, you pay for those as they're used. When you remove those compute resources, you're no longer paying for those compute resources. If you're using storage or bandwidth, you're using storage and bandwidth based on the amount you use. You're not paying for some maximum that you may never use. You basically just pay for what you use. Your usage can also be monitored and controlled at any time. You can do reporting, and this provides transparency for the provider of the service as well as you. One prominent analyst in this area basically equates cloud computing with the old time-sharing model back in the 60s and 70s. So for people like me who go back that far, you might get a chuckle out of that, or basically going back in time once again. There are three different deployment models for the cloud, something called a private cloud, the public cloud, and a hybrid cloud. A private cloud is provisioned and used exclusively by one single organization. It may be owned or managed by that organization or some third party. So for example, InduSoft has our own private cloud that we've provisioned internally using off-the-shelf software, and we use that internally for development, QA, and support purposes. So as we need to do different customer scenario testings or different load testings, we can provision services on demand, and then when that testing is complete, we can free those up for use by other applications and needs. In our case, that's on-premise, but private clouds can also be off-premises. The different cloud vendors sell their services such that they can actually look like they're physically part of your network using virtual private networking. There are also public clouds where you are using services that's available to the general public. It's owned and managed by the service provider. Generally, some business, a academic institution, or even a government organization might provide a public cloud for general use. And these always exist on the premises of the cloud provider. And then there's a hybrid cloud. Some companies out there might have a need for a combination of public and private clouds. One reason to do this is that you have specific internal needs that only you require, but then you might need some public access for maybe your customers or consumers to be able to access. So you might use some public entity cloud that is connected to your cloud. From your perspective, they all work and access together. From the consumer's perspective, they have easy access from the outside world. There are three defined service models for clouds: infrastructure as a service, platform as a service, and software as a service. Infrastructure as a service basically allows you to run off-the-shelf applications just like you would on your own IT infrastructure. Infrastructure as a service allows you to provision computing resources on demand, again, only paying for what you need. The consumer does not need to manage or control the underlying infrastructure, but the consumer does have control over what operating systems are run, how the storage is deployed, what applications are deployed, and setting up various networking components like firewalls. So two prominent players in this market would be Amazon Web Services. They are the most mature and largest provider of infrastructure as a service, and Rackspace Cloud Service, who is a traditional hosting company. Platform as a service is one of the newer cloud models. Basically, it provides a set of software and development tools that allows other companies and consumers to create their own applications and host them over the internet. The consumer, in this case, does not manage the underlying cloud infrastructure like the operating system and patches to the operating system, but they have control over their own deployed applications and the application hosting environment configurations. Not the actual hosting environment itself, but the ability to configure it in different ways. Users who use this service develop their software using common off-the-shelf and development runtime platform. This allows them to provide standard look and feel and allows their developers to use a common platform and provide consistency across their code. The two major players in this space is Microsoft Azure and the Google App Engine. So in the Microsoft case, if you use a .NET-based application, then it's fairly easy to move that .NET-based application into the cloud. Google App Engine supports programming languages such as Python and Java and allows you to run those applications on top of their application engine. Software as a service is probably the oldest cloud model that's been out there. In the case of software as a service, consumers can use providers' applications that are running on some cloud infrastructure. So, for example, Hotmail, any of the email services are basically software as a service models. Google Apps, for people who might use Google Apps, is software as a service model. Salesforce.com is probably one of the most popular and longest, most mature software as a service applications. So rather than go off and buy someone's software and deploy it yourself, they provide their software on the internet. Consumer doesn't have to manage or control the infrastructure, and the consumer only pays for what they use. There are many benefits to cloud computing: economic flexibility or agility, accessibility, reliability, and security. Economic benefits is one of the big reasons that people move to cloud computing. Instead of having a huge capital budget to go off and buy equipment, companies can basically move to an expense budget and only paying on a monthly basis for the resources that they actually need and use. It provides, again, access to almost unlimited processing power and storage, and customers can provision this as needed for things like historical databases and only pay for the actual storage that they're using. So rather than buy some big database that you may fill up over time, you can purchase storage via a cloud provider and only pay for that storage as it actually increases over time. Again, allowing you to one, spread that cost over a period of time, as well as reduce that cost because you're not paying for the whole thing at once. It also allows you to have redundant hardware and software disaster recovery. If you needed to do that in your own company, you'd have to, set up some disaster recovery site, some redundancy site, and you may never ever use that. Using cloud model, you can set policies up and processes up such that if you have a failure, you can automatically provision new services on demand, possibly in other data centers, and you only pay for that when you actually need to do that. So that's a huge cost savings for customers who need to provide high availability solutions. Better agility. Building an IT infrastructure takes lots of planning. It takes months to purchase, install, test various bits of equipment. You can provision equivalent resources in a few minutes. If you are in a process of evaluating some application or software, rather than go buy hardware to test that out with, you can provision a server at Amazon or Rackspace, for example, and in less than 5 or 10 minutes, you'll have a machine up and running that you can begin your testing on. You're not waiting on a vendor to sell you hardware or ship you hardware or your IT organization to install hardware. And if you provision something that's too big or too small, you just start over. You provision a bigger machine and a smaller machine, and again, in 5 or 10 minutes, you're off and testing again. Agility also is improved by allowing you to provision these resources, again, on demand. There's no financial or resource commitments, and the risk is very much reduced because you're not making a huge investment that, after a few months you decide isn't working out and you decide to go on some other route. You can pay literally using Amazon or Rackspace, a few $100s to run an application over the course of 2 or 3 months, and if it doesn't work out, you're out a couple $100. If you invested that in hardware, then you'd have to find some other use for that hardware, or that money would be lost. Agility is also flexibility. If your business changes, either because you're growing, you need to add users, or you have other applications coming online, using cloud resources, you can easily scale up, scale down to match that and to add resources on demand. Accessibility. Many customers out there have very large IT organizations, very large and good internet access. There's a lot of companies out there who are smaller and don't have redundant internet connections and redundant power connections. Using cloud applications, you get the benefit of the cloud provider. Cloud providers are going to have redundant power. They're going to have redundant servers. They're going to have redundant internet connections. So if you have customers out there on the internet that need to access your application, you don't need to provide, failover applications. You don't need to provide endpoints in Singapore and Japan and the U.S. and South America. You can use their resources that already exist, and if something happens, a user will just automatically be routed to the next nearest connection or internet provider. Improve reliability. We talked about some of these already. Redundancy and disaster recovery abilities are essentially built into many cloud computing environments where you can increase resources on demand or fail over to even other data centers on demand. Backup and recovery processes are generally superior to those of again, sort of small organizations that don't have the resources to either provide cloud-based or backup and recovery solutions that can provide the ability to do disaster recoveries. Data maintained in the cloud could be more available and faster to access. Many customers do backups and they store it offsite in safes or locked areas, and if they have to recover data, they have to go get it. By backing up your data to the cloud, it's immediately available, and if you need to access that data because you're having an issue in your own data center, then that's immediately available. Superior security. Part of this comes from the fact that the cloud providers are just huge organizations that allow them to focus on security. Many of us have security folks. They're responsible for security, but they have other jobs. If you look at the staff of some of these cloud computing vendors, they have people. That's their only thing. They concentrate exclusively on security issues. The uniformity of the cloud computing platforms also generally provides better security because they provide common and homogeneity with respect to the platform, common configuration control, common testing, common auditing, and common patching. So it allows them to streamline their security, which then you get to leverage as a consumer of their service. As there are many benefits, there are multiple challenges to using cloud computing. The complexity, protection of your data, availability. So some of the opposites of what we have just talked about. Internet-facing services, multi-tenancy, loss of control, and then threats from external sources like botnets. System complexity. If you look at a cloud computing environment, it's extremely complex compared to a traditional data center. There are lots of moving parts, and because of that, you are dependent on the cloud provider to make sure that they have their act in line, that they are providing the level of security that are needed. The pure number of possible interactions. If you look at the infrastructure of a cloud infrastructure, they have network-based storage. They have multiple network infrastructures. They have multiple servers on multiple subnets. And again, that's just because of the sheer number of interactions between the resources that makes them more complex. So relying on the cloud provider to both manage that reliably, provide security reliably, is a potential vulnerability. You clearly want to be able to look at the cloud provider and make sure that they're providing manageability of that complexity, so that if you make that choice, you can be comfortable with it. Data protection. If you're looking at something like a public cloud, there are other users on that public cloud. They may be competitors of yours on that public cloud. And again, data protection of your data in the cloud should be important to you. If you have sensitive or regulated data, then accounting for that, making sure that the cloud vendor provides adequate protection based on that is something that you will want to make sure the cloud provider does for you, because your business could potentially depend on that. Availability. We talked about availability and accessibility as a benefit. Well, it's also to some extent a downside. You are dependent on them to be available, and as we'll talk about in a second with loss of control, if they're not available, you have no control to make sure that your applications are available. If you hosted your own data center and something happened, you could at least go deploy resources to try to go get it fixed. But with the cloud, you are totally dependent on them providing the services according to the service agreement that you signed up for. Internet-facing services. If you have an application and it needs to be internet-facing, then whether you host it or whether you host it in the cloud, you're going to have some issues and some security threats. But if you're just using internal applications and you have no external users, going to a cloud service is going to add some security threats, because the cloud is on the internet. It's not in your domain. You can't firewall it off from everybody else. It's out there. They're susceptible to all the same risks that other internet service providers or applications are susceptible to, and you need to make sure that they're providing the level of security that you need for your application if you decide to choose one of the cloud services. Multi-tenancy, again, there are unknown parties out on the cloud, maybe actually sharing resources with you, and you need to account for that in your plans and your processes. Your data might be accidentally exposed to other consumers of the cloud through a configuration or a software error. An attacker who's using your application, they might be some hacker or some competitor. They might try to access your application and pose as a user to try to exploit vulnerabilities in your application or get access to the data in your application. Loss of control, I mentioned earlier. If something happens, you have no control to try to resolve that issue. You're totally dependent on the cloud provider to provide the service. And if something happens, you are largely in their control, in their scope of control, to make sure that it gets fixed. Botnets and threats. Again, the clouds, through their nature, are attached to the global internet. And as many of you probably know, there are lots of threats on the internet. People are trying to break in and hack and just cause trouble all the time. And cloud infrastructures are going to be no different and are no different than other infrastructures. In fact, there has already been one botnet that's been discovered on one of the leading cloud providers. So, this is a clear threat. The cloud providers know this is a clear threat. And, you need to take that into account. And it's one of the challenges and one of the possible security issues that you'll have to deal with. If you have your own application inside your own data set, you can totally fire it off, just unplug yourself from the internet. You're isolated. May not be a reasonable expectation, but you at least have that control. Using a cloud service, you have, again, no control over managing like that. You're totally dependent on them. So I'm going to hand it back over to Fabio, and he'll talk about a few architectures that people use in the cloud.
Thank you, Larry. So really briefly talking about some typical architectures from real-world applications deployed with InduSoft Web Studio on the cloud. So the first one is what we call the communication with RTUs. In InduSoft, we actually, from the cloud modules, we designed the product to be compatible with infrastructure as a service. And when you design the application with InduSoft Web Studio and deploy on the cloud, the actual application for your users is seen as a software as a service, because the end users just consume the application that you deployed on the cloud, and you deploy InduSoft Web Studio on the cloud in an infrastructure as a service cloud running any Microsoft operating system, typically Windows Server 2003 or Windows Server 2008. And another interesting advantage of the InduSoft solution is the fact that it supports both on-premises and off-premises clouds. You can deploy the application in a Hyper-V virtual machine on your own organization, or you can deploy exactly the same application on a off-premises cloud, a public cloud like Rackspace or Amazon, without doing virtually any changes on the application. We'll be changing some IP addresses in your scripts and things like that, but you do not have to modify the core configuration of the application. Moreover, even legacy applications that used to run in real computers, in standalone computers, can very easily be updated or deployed in virtual machines or on the public cloud, again, without any major changes in the application configuration. So for InduSoft, we have an interface with the operating system, and as long as this operating system is a Microsoft one, whether it's running a standalone application computer or in a virtual machine, is pretty much transparent for InduSoft Web Studio. On the cloud-based applications, we have seen in many of them, the server, the InduSoft application running on the cloud is pretty much a consolidator of data from many different devices, which are typically PLCs, but generically we call remote terminal units. Could be controllers, could be remote IOs, could be programmable logical controllers, doesn't matter. So InduSoft Web Studio running on this virtual server on the cloud would be able to run the native drivers from InduSoft or even the OPC interfaces, OPC UA, OPC XML, all the modules available in InduSoft, and communicate with the RTUs. And all you need is a TCP/IP link between InduSoft Web Studio and the actual RTUs. InduSoft then typically collects data from those remote RTUs and saves data into a SQL relational database, also on the cloud. And another advantage of using a infrastructure as a cloud is because we have much more flexibility and the power of choice on the tools that you actually deploy on the cloud. You can choose the actual operating system, given a set of options. You can choose the database you want to use, if it is Microsoft SQL Server, or if it is MySQL, or if it is Oracle. Again, the mindset and the tools you use are very similar to a standalone computer. You just take advantage of the fact that the actual hardware is scalable according to your needs. And then this server running the InduSoft Web Studio and collecting data from the remote RTUs saves data to the database, and using the web solution from InduSoft, this information can be available from remote thin clients. And InduSoft Web Studio supports 3 different types of thin clients. One is what we call the web thin client. You open Internet Explorer in a remote computer, type the URL for your server, could be the virtual server running on the cloud, and then you have access to the graphical screens, online information, history information, just like if the server was running in a physical machine. The access to the application is complete. You can configure the InduSoft security system to restrict access to data and to screens based on username and password. But from the functionality point of view, everything available to the central server is available also to the remote web thin client. And all you need is a remote computer running Internet Explorer. The second solution is running InduSoft Secure Viewer Thin Client, typically with a Microsoft remote desktop on the cloud. So you can deploy InduSoft Web Studio Server in one virtual machine on the cloud and deploy Secure Viewer, pretty much install Secure Viewer in a second virtual machine, which is configured to initiate one independent remote desktop for each remote connection. So from remote devices where you can run a remote desktop application, and it includes iPhones, iPads, Android devices, or computers, PCs, iMacs, you can just run a remote desktop section to the virtual machine on the cloud where Secure Viewer from InduSoft was installed, and it launches an independent thin client section for Secure Viewer, which is connected to the main server where all the information is available. So from any device with a remote desktop application, and Androids, iPhones, iPads have even free applications available for remote desktop, you can visualize a InduSoft Web Studio application as a independent user. And the third and last thin client solution supported by InduSoft is what we call SMA thin client. So from any device with a web browser, including the old cell phones, Nokia phones, any device with a web browser, you can pretty much type the URL for the server and visualize tag values in real time and visualize online alarms and even acknowledge the alarms. And all those solutions are they are linked to the security system, built-in security system from InduSoft, so you can control the access to those screens, to this information, based on username and password. Even though we have seen several applications communicating with RTUs and things like that, and like Larry mentioned, the cloud provides you a lot of tools to make sure that your server has a high availability, redundancy, and data storage and everything else. The actual link between the RTUs to the cloud is not 100% reliable. In other words, if your RTU loses the connection with the internet, assuming that your server is running on Rackspace or Amazon, then the server on the cloud will be unable to pull data from those remote RTUs. So this architecture with store and forward capabilities from InduSoft Web Studio provides you the reliability and availability that many applications require. So you still have InduSoft Web Studio running on premises, reading data from the local controllers, saving data maybe to a local database, and filtering this data and pushing this data to the server on the cloud as needed. So number one, you don't have to pull data from the RTUs. Each RTU can push data to the cloud, which makes the system even more scalable from the performance point of view. Moreover, if you lose the connection between one site and the cloud, the local HMI running the InduSoft Web Studio has the capability to store the information in a local database and eventually forward this information to the cloud. So you do not lose data even if you lose the connection with the cloud. And having said that, I will pass control to Darryl Vipond from Vipond Controls, and he will demonstrate a real-world application deployed by him, by his company, with InduSoft Web Studio on the cloud. So Darryl, I made you the presenter. Feel free to share your desktop as soon as you are ready.
Thanks, Fabio. Good morning, everybody. Yeah, we have a real-world application that's running on the cloud, and we call it iSCADA. And this application was developed primarily for the oil and gas industry, but a lot of the principles can be applied to other industries as well.
And Darryl, sorry to interrupt. I don't know if you have two monitors, but so far we can see just a blue desktop.
Yeah, okay. Can you see that, Fabio?
Yes. There you go.
Okay.
Thank you.
So over the past 10 years, remote well site monitoring has moved onto the internet. Traditionally, a lot of companies have had their own SCADA systems on-premise with their own people to look after them. And a lot of the smaller companies really didn't have the resources to buy the software, to hire the people and the contractors, and to maintain their own SCADA system. So over the last 10 years, a number of companies have developed web-based remote well site monitoring systems, and this one here is one of them. So if someone who's working at an oil and gas company wanted to see the flow rate of one of their wells, they would open up their web browser and log on to one of these sites. And from there, they could see their wells. And some of these companies have become quite popular with smaller producers because they don't have to maintain their own hardware and technical staff to build and support their own SCADA systems. But one of the common complaints that we get from operators and engineers is that this actually is a web application. So let me just log in again here. And web applications are pretty much a point-and-click stateless style of application. So it doesn't really have much of an HMI look and feel to it. So if you're trying to operate a well with this SCADA system, for instance, it's a lot like a web-based application. You click and point and it update and refresh, and it doesn't really have an operator point and feel like a traditional HMI would. So one of our goals was to create a system that's very similar for remote well site monitoring, but has a much more HMI look and feel to it. And so that's what we set out to do. And we chose InduSoft and cloud computing and software as a service architectures and software to do this. And we felt InduSoft was very well suited for this because of its scalability, cost structure, and view client options. So, as you can see on this leading web-based remote well site monitoring system, if I click on, if I wanted to see my flow rate, for instance, click on that, it brings up a trend like this. So it's very web-based. You get updates perhaps 1 hour, and to do any kind of operating of the well, like starting, resetting, changing flow set points, it's quite a lot of effort. Now here is our iSCADA product from one of our customers, and this is InduSoft running on the cloud, and you can see it's a traditional HMI system, and it has much more HMI look and feel to it. A lot easier for operators to go in and make changes and to monitor their wells. There's the alarm banner. A lot of things that typically you'd expect an HMI to look like is what you'll find. And then trending, quite a bit more of a traditional HMI type of trending and reporting and operating. And so you can see it's a little quicker and a lot easier to operate. So the backbone of this system is a cloud computing architecture. So on this platform, each customer gets their own virtual machine. InduSoft, along with our framework, is loaded onto this machine. The InduSoft system will communicate to remote sites, usually via a cellular modem, or a phone line, or a satellite connection. And usually, VPN tunnels are established between the remote sites and the iSCADA server. They're not over the raw internet. Users access the system via a secure RDP connection to a terminal server running on our cloud platform. The remote viewer.exe program is published on this terminal server, and based on users' credentials, the remote viewer is pointed to the correct client InduSoft machine. And here's just a few more examples of our iSCADA. We have a wind farm here as well. Let me just maximize that. And this is somewhere in Ontario, and it's pulling data from the wind farm. And people can log in. It's completely view only. There's no control on this, and see what's going on with power and wind and velocities, ambient temperatures, things like that. And here is a picture of a typical well site that we would find iSCADA on. And if you look down here, this operator, you don't know you got the panel open, but this is an iPad, and he is actually operating the well with his iPad wirelessly connected to iSCADA. And the speed and the operability of this just makes it convenient that they can do that. And you can see the iSCADA running on his iPad. So, what are the benefits of iSCADA versus a traditional internet-based remote well site monitoring system? Well, users have a real-time HMI look and feel, which makes it easy to operate the remote wells. Each company gets its own machine, its own virtual machine running on the cloud, and that also gives them some flexibility on how you set up your application. You can customize it. You can add your own graphic libraries, better increase if you want different type of trending, or if you wanted better different types of reports or anything like that. You can do that. With a traditional web-based application like this, it's every user gets the same interface, and there is no customization without causing them to create something custom for you, which would be a lot of money. Another benefit of iSCADA using InduSoft right on the cloud is it's a lot easier to train people to maintain and add wells and make changes with InduSoft versus bringing in web developers, database guys, and Java and Visual Basic to maintain a website. Another key benefit of iSCADA is the system is designed to allow remote support of the well sites. And this is something unique to iSCADA. It's something that can only be really, I think, possibly done in a cloud computing architecture. Is, for instance, say this particular well site here needs a programming change done to it. Now, some of these well sites are quite a long ways from nowhere, and it takes hours to drive out them. Some of them you even have to helicopter into. And so it's possible to pretty much fire up the RTU configuration software and connect onto the controller and make the changes. And that's something that a lot of customers find really valuable, and it also increases their efficiency and uptime and all that. And another benefit of cloud computing, and Fabio pointed this out, is that if you have like a larger facility, like say a compressor station, and you don't trust the internet, and you don't want to be totally dependent on the cloud computing architecture to view your compressor station and operate it. So what you can do is you can, we've done this with a couple of customers, is locally install a computer that runs the InduSoft in the framework, and it talks locally to the compressor controller, but all the wells and facilities that feed into the compressor, they're upstream and downstream. It will connect over the internet and the cloud into the cloud server and pull that data and present it to the operator. So it's a bit of a hybrid system. And so if the internet goes down, he can still operate his compressor without having to worry about network connections. And when the internet comes back up, he can go ahead and see his field. For future plans of iSCADA, as we get more customers, we will continue on increasing our data centers to geographically disperse them in different areas, and to increase the high availability of our servers with replication between the different data centers. And as virtualization technologies develop, we intend to utilize those technologies to reduce cost, increase availability, and to make it easier to deploy new machines. And I'll just give it back to you, Fabio.
Thank you very much, Darryl. It was excellent. I appreciate you sharing your application, your design with us, and it's a great illustration of the concepts that we have been discussing here. So having said that, I'd like to open for Q&A. And if someone has any questions, feel free to type them on the chat or in the Q&A box. So this one would be, I'd say, more for Larry. When would you suggest to have an on-premises cloud system versus a public cloud system?
So the on-premise cloud would be if you want to have all the benefits of cloud, but you want to be able to have the control and minimize security and access issues. If you have an application that needs to be scalable, if you have an application like Darryl's where you need to provision resources based on customer acquisition, then you can create your own hybrid cloud using very cost-effective or cost-efficient computing stack and provision servers on demand as you need them. Either grow servers, you can add CPU, you can add memories to servers, or you can just add new servers like Darryl's application. And you're not dependent, in this case, on the cloud provider or the internet. Now, some of the downsides of that is that, your customer then is dependent on you and your internet connection and your power connection. But, depending on your needs, if that's something you want to manage, then creating an on-premise cloud is a perfectly reasonable thing to do in that case.
All right. Thank you, Larry. Another question here is, can you discuss technical methods to get data from RTUs to cloud applications such as OPC versus FTP or flat files and so on? So, first of all, there are systems where you need both online and history data, systems where you need online data only, and systems where you need history data only. So let's divide between online information and history information. For online information, going back to our typical architectures, if you are communicating directly with the RTUs, typically what we use is the actual a native driver for the protocol supported by the RTU, by the remote PLC. Many systems, many RTUs support Modbus over TCP/IP, but you could use any protocol for which there is a driver in the InduSoft Web Studio. OPC is also an option for online data, primarily for online data. And OPC-DA, also known as the classic OPC, in my opinion, is not suitable for networking stations, even in a local area network, much less for a remote system like a cloud-based system. And OPC Foundation, aware of that, developed new interfaces, OPC XML, and more recently OPC UA. And InduSoft Web Studio supports those two interfaces. And if you want to communicate with a remote device via OPC, I strongly recommend using OPC UA or even OPC XML rather than OPC DA. And those are pretty much the methods for online data if you're reading data directly from an RTU. If you have a system with a local InduSoft Web Studio on the RTUs, a local HMI, and you want to provide online data to the system on the cloud, InduSoft Web Studio has a built-in TCP/IP client and module, client and server modules. So the local HMIs can push data to the central server based on exceptions, only when the values change of values, using the standard TCP/IP client and server modules from InduSoft. For history data, then there are typically two methods to do that. One would be the built-in store and forward capabilities from InduSoft Web Studio. In the previous webinar, we discussed this option and this configuration in details. We went through how to configure, store, and forward with InduSoft Web Studio. But pretty much, if you have InduSoft on the local HMI, it can save data to a local database and forward this data to the central server, in this case on the cloud, automatically. The configuration is very, very simple. Other ways, especially if you do not have InduSoft Web Studio on the local HMI, would be to push flat files or pull flat files using standard protocols, and FTP is pretty much the standard one that we have used in real-world applications. Another question would be more for you, Darryl, if you don't mind, is how much more work was involved in deploying InduSoft on the cloud versus deploying InduSoft on the premises as a standalone application?
Well, that's a good question, and the amount of work difference is really not that much when it comes to provisioning resources. You still have to, for us, what we've done is after we've built it once, we copy it many times, and we continue to do that, whether it's it's on the SCADA cloud or whether it's local to the customer, is that we build the machine, we get it set up with InduSoft, we get our framework in there, and then if it's a virtual machine, it's really easy to replicate. It takes probably 2 minutes. And then the machine's up and running. We put the new licenses on. We customize the application a little bit for the customer, and we're done. So using these concepts of cloud computing, virtualization, I think it really reduces your workload considerably for setting up new machines.
Thank you. Appreciate it, Darryl. Another question here, can you further discuss the use of iPad as a terminal for InduSoft application both on the cloud and from a local server? Yes, and the nice thing is that the configuration is pretty much the same whether the server is on the cloud or in a local server. So pretty much in one station you install InduSoft Web Studio, which runs the communication drivers, it stores data to the database, let's say the server per se for the application. Doesn't matter if it's a local server or a virtual server on the cloud. In another station, which could be a virtual machine, could be a VM on the cloud, could be another physical computer, you install InduSoft Security Viewer, which is another executable from InduSoft, and install it typically on Windows 2003 server or Windows 2008 server. And using the Windows tools, and there is a blog in our website where we describe this in details, but using the Windows configuration, you can configure that station to create new instances of the desktop, in this case of Security Viewer, every time that a remote node connects to that computer using a remote desktop connection. So from an iPad and Android, you can install one of the many remote desktop applications. Like I mentioned before, there are several applications that are even free and provide remote desktop connectivity. And then you install one of those apps in your iPhone, iPad, or Android, configure this application to connect with the VM or with the actual computer where Security Viewer is installed as a remote desktop server connection. And then from your iPad, you just launch the remote desktop. It starts a new instance of Security Viewer, and you have a unique view for the application. And each one of the instances from Security Viewer running as a remote desktop connection connect to the server running InduSoft Web Studio and share the online values and the history data from the application. Another question here is how about Android-based tablets as InduSoft HMIs? This thin client solution that we just described is valid for Android devices as well. the actual runtime, the server portion of InduSoft at this point is Windows-based, and we are focused to provide the graphical interface as a secure viewer thin client or web thin client on different platforms, including Android and iPhones. Another question is if InduSoft Web Studio 6.1 is supported in virtual environments. It has not been fully QA'd in virtual environments, but we are aware of customers that use version 6.1 in virtual environments. So there is not technical reasons at this point to prevent you from deploying InduSoft Web Studio 6.1 in virtual environments. But we recommend using version 7 if all possible, because this version has been specifically QA'd and even some features implemented in version 7 to make it more suitable for a virtual environment. How about throughput? How does cloud architecture affect the number of samples collected? Is it guaranteed that samples will reach SCADA in correct order while traveling over the internet? You want to tackle on this one, Larry?
Yeah, sure. So from a networking perspective, generally speaking, devices are still going to attach to the InduSoft server using some form of Ethernet in this case. Whether the server is local or whether the server is on a machine, half a world away, it's still using Ethernet and generally TCP/IP or some IP-based protocol. So there should be no difference with respect to the transfer of data and certainly the ordering of the data. Now you're always dependent on the speed of the connection. So Darryl mentioned that they use multiple connections, including cellular and satellite. We have customers who use different radio-based connections, and you're never going to get better performance than that provided by the connection. So you have that issue to deal with, but that issue exists whether or not again the server is local to your data center and on-premise, or the server is in some cloud provider's data center. Basically, it's TCP/IP communications, and you should see no difference. The only issue you're going to have really is the speed of the connection, and you have that regardless. The advantage to going to the public cloud versus the on-premise cloud also gives you the ability to have multiple internet backbones. All these cloud providers are going to have 4 or 5 different internet providers, such that if one goes down, you're going to be routed to another provider. Most companies, even large companies, can't afford to provision and set up and configure multiple internet connections. So you're actually going to get better performance on the network using the cloud provider than you would doing a similar WAN-based connection across to your own data center.
Great. Thank you, Larry. Another question here, is InduSoft only supported running on Hyper-V, or are other virtual environments supported, such as VMware? And the good news is InduSoft Web Studio is compatible with other virtual environments, including VMware, as long as the operating system on that virtual machine is a Microsoft operating system. So whether you use Hyper-V, VMware, or any other virtualization environment, InduSoft will be compatible with it, or at least the ones we tested so far, we didn't find any incompatibility, as long as the OS running beneath it is a Microsoft OS.
And I'll add one more thing. For people who are familiar with the virtualization architectures, InduSoft is also compatible with VMware's vMotion and Hyper-V real-time migration. So you can actually move your virtual machines between physical servers without any data loss and transparent to the user and the application.
Very well. Another one, if I have an application running InduSoft 6.1, can I have Web Studio 7.0 on the cloud? You can, and 6.1 and 7.0 can exchange online data through the TCP/IP client server modules available on both versions, and they can share also history information available on SQL relational database. And if there are some communication challenges, compatibility to have a 7.0 on the cloud and 6.1 on premises, there is not any, at this point, known issues or challenges, just by the fact that the versions are different. I would say maybe one is if you make changes on the application with InduSoft 7.0, with the development environment for InduSoft 7.0, those changes cannot be executed by the runtime running version 6.1. So if you want to make changes on the current runtime applications running 6.1, the changes for those applications must be made with the development environment for 6.1. Other than that, I do not foresee any major challenges. One more question. With the wide range of remote connection viewing devices, is development for various screen display resolutions a problem? The good news is both Secure Viewer from InduSoft, the WebThing client from InduSoft, and even the remote desktop applications have built-in features for automatically scaling your screens. So regardless of the resolution on the device, the screens will be automatically rescaled. The challenge here is whether it's very convenient many times and helps you to see the whole screen. Sometimes you might reach a physical limitation there. If you design a large screen that looks great in a large monitor and you try to view this screen in a cell phone display, everything could be as small that you cannot even read the information. It cannot be operational. So in InduSoft, we allow you to create on the same application screens with different sizes. And then you can create a set of screens more suitable for cell phones, a set of screens more suitable for devices, a set of screens more suitable for large displays, and all those screens can reside on the same application. And when the user logs in from a thin client, you can give him the option to visualize the screens for the type of devices they're using.
Yeah, and this is Larry. I can add one more thing to Fabio's description. Most of the new smart devices today, whether tablets or phones, iPad, iOS, or Android, allow you to have multi-touch, pinch and pull ability to resize and zoom into your display. So you could actually have, in fact, we do it here all the time, run InduSoft on like an iPhone, and you get the full display of the application on the iPhone, and then all you have to do is using multi-touch to zoom into any area you want, and then again using multi-touch you can pan around the screen and even execute commands on the screen. So you get your two choices, as Fabio mentioned. You either create specific screen size to an application, or you can let your users use a full-size application and let them use the functions that they already know on their phone to zoom in and out and pan.
Thank you, Larry. And with that, we are a little bit over 1 hour here. I would like to thank Darryl very much for sharing your application and your knowledge with us, Darryl. And I'd like to thank everybody for taking the time to participate on this webinar. You can see information on how to contact InduSoft, and this information is available on our website as well. We'll be sending this PowerPoint presentation and posting this video on the website, and everybody on this webinar will receive a link to access the video and to download the PowerPoint. Again, thank you very much for your participation, and I hope to see you again in the next InduSoft webinar. Have a nice day.